section 8 for today. If you have chemistry, have taken chemistry, then this section will be probably a complete review for you. This is a section that I would call a section on unit analysis, kind of changing from one measurement to another measurement, and our author calls it dimensional analysis. But for what it's worth, most of the problems that we're going to be presented in this section give us a number with a label and want us to change it to another, find an equivalent quantity with another label. For instance, problem 10 in this section wants me to convert 9 pounds to kilograms. In order to convert 9 pounds to kilograms, somehow I need to know a relationship between pounds and kilograms. And to find that relation, in fact, most any relation I'm going to use in this section, there's a table on 461. I look down to the bottom of the table. It says that 1 pound is 0.45 kilograms. I'm going to use that fact to figure out the answer to this problem. So the first group of homework problems that I picked in this section are from 9 to 23. And I think I can lecture and explain how to do the problems without doing a lot of theory. So basically, for every problem between 9 and 23, I'm given a quantity to start with, and I have a goal. In this case, my goal is to convert 9 pounds to kilograms. In order to do this, I need to have some sort of relationship between pounds and kilograms. And I use that relationship from the top, from page 461. And for each one of these problems, to get my answer, I'm going to multiply by a fraction, and this fraction is going to be equivalent to 1. In the numerator of the fraction, I'm going to put what I want. In this case, I want kilograms. In the denominator of the fraction that I multiply, I'm going to put what I have. So to convert 9 pounds to kilograms, I'm going to multiply by a fraction that's equivalent to 1, and what I want is kilograms. What I have is pounds. When I do this multiplication, I'm not changing what the original problem. My answer is going to be equivalent to 9 pounds. It's just not going to look like 9 pounds because I'm multiplying by 1. If I multiply any number by 1, I don't change the value in some sense. But now I'm going to change the units. So this 9, because it's not written as a fraction, is considered in the numerator. I could cancel the pounds with the 9, which is considered in the numerator, with the pounds in the denominator, and I'm left with 9 times 0.45. The units that are going to be left are kilograms. My fraction is gone because there's only a 1 in the denominator, and the operation that I need to do to solve the problem is I need to multiply 9 times 0.45. Doesn't matter if I put the 0 to the left of the decimal or not, but it's fine if I do. When I do the multiplication, the 9 times 0.45, it gives me 4.05, and the units that are left are kilograms. The nice thing about this section is I really don't have to understand the metric system at all to do the problems that involve metric measurements. In this particular problem, I understand pounds. I kind of understand that kilograms are kind of similar to pounds, but I'm not really that good with kilograms. But I didn't need to really have a good understanding of the metric measurement of kilograms to get this problem solved. Similarly, the next problem, problem 12, the next even problem, wants me to convert from G, which stands for grams, to ounces. Did the same thing. I went to the same table on page 461. I found this measurement that said 1 ounce, and it abbreviated ounce OZ equals 28 grams, and grams is abbreviated as G. Some of the problems, you might not know what the abbreviation stands for. You probably could hunt on this page and find almost any abbreviation that you need for this particular section. So anyways, I looked at my table. My table told me that 1 ounce was equal to 28 grams. And just like I did problem 10, I'm going to multiply by a fraction. In the numerator, I'm going to put what I want. In the denominator, I'm going to put what I have. And what I want is ounces. So I want my answer to be in ounces. And the units that I have are grams. And to do unit analysis or dimensional analysis, I multiply by a fraction that's equivalent to 1. In the numerator, I put what I want. In this case, I want ounces. And I'm going to use the fact that 1 ounce is equal to 28 grams. I'm going to put the 1 ounce in the numerator, the 28 grams in the denominator. I can write out the word grams, or I could just use the letter G to stand for grams. It doesn't matter if I use abbreviations or if I use the full word. This is the setup to solve this problem. So I'm taking the 127 grams, I'm multiplying it by a fraction that is equivalent to 1, because 1 ounce is 28 grams. This is really 1 ounce divided by 1 ounce. This allows me to change the units. In the grams next to the 427s considered in a numerator, it will cancel with the grams that's sitting in the denominator. And the units that I have left for my answer are going to be ounces. So when I do the work that's implied here, my answer is going to be ounce or ounces. I'm plural because I'm probably getting more than 1 ounce. In this particular problem, because the 28 is in the denominator, I have to divide as opposed to multiply. In problem 9, because the 0.45 was in the numerator, when I solved the problem to get my answer, I multiplied. But in this problem, because the 28's in the denominator, I have to divide. So I'm going to just go 427 divided by 28. And I get 15.25. I didn't read to figure out where the author wants me to round, but hardly seems like a reason to round that. That seems like a clean enough number, so I'm not going to round it at all. And I'm going to write 15.25 next to the word ounces. And if I wanted to, I could have written an abbreviation for ounces as OZ. Most every problem in this grouping between 9 and 23, this is exactly what I'm going to do. I'm going to take the initial quantity, write a time sign and a fraction next to the initial quantity. In the numerator, whatever units I want to get out, I'm going to put in the numerator. In the denominator, I'm going to put the units I'm trying to get rid of. There's some tricks, but not too many. So next problem, even problem, is 14. I want to change 160. That kg means kilograms. So I'm going to start off with the number that's given. I'm going to multiply by a fraction. In the numerator, I put the units that I want. I want pounds, and I understand that pounds is abbreviated LB. So I'm going to write 1 LB in the numerator. And then in the denominator, I'm going to put the units that I'm trying to get rid of. I'm trying to get rid of kilograms. And again, I got this same, this is still from the chart on page 461. You don't need to memorize this chart. When it comes to the test, I'll either let you use a note card or I'll write down on the board the units that you need. So you don't have to worry about memorizing all these equivalents. This is not that important. So now that I have my fraction set up, the kilograms cancel. I'm going to be left with pounds, or LB I can write. And because the 0.45 is in the denominator, to get my answer, I need to divide these two numbers. So I'm going to take 160 and divide it by 0.45. If the unit that's not the one is in the numerator, you multiply. If the unit that's not the one is the denominator, you divide. And I don't know what to do in terms of rounding. The author just doesn't say about rounding, so I'm just going to round it 2 decimals, and my calculator gives me 355.555. To round to 2 decimals, I look at the number in the 3rd decimal position. If it's 5 or bigger, I round up. This 5 is going to cause me to round that 5 up to a 6. So I'm going to write 355.56 pounds. On a test, if an answer needs to be rounded, I'd like to think I'd tell you how many digits I want you to round to. But because our author doesn't tell me, I just 2 seems like a reasonable amount. So, and for that matter, if I forget to tell you how to round something on a test that needs to be rounded, and you randomly, arbitrarily decide to go to 2 decimals or 3 decimals, I'm not going to take credit points off. If you round correctly and I don't tell you where to round to, then your rounding has to be just fine. 16 is a hard problem. It's first of all, 16 assumes that we had covered, I think, section 8.2, possibly section 8.1, that talks about the metric system. And we didn't talk at all about the metric system, and I suspect that most of you don't remember how to convert in the metric system. When I went to solve 16, I looked at the chart to find a relationship between millimeters and inches, and in the chart on page 461, there wasn't a relationship between millimeters and inches, but there was a relationship between centimeters and inches, and that's the only length that I see that has inches related to a metric unit. So I knew I was stuck using this fact that 1 inch is 2.54 centimeters. Unfortunately, the length I was given is in millimeters, and had we done section 8.1, we'd know how to convert from millimeters to centimeters, and then I can go from centimeters to inches. So I'm going to do this in 2 steps. The first step I have to do, because I don't know a relationship between millimeters and inches, but I do know a relation between centimeters and inches. The first thing I'm going to do is I'm going to convert from millimeters to centimeters. And if this was a test question that I wanted you to do this, I would give you the conversion that you need. So if you don't know how to work in the metric system, it's fine to convert from millimeters to centimeters. If I give you the fact that 10 millimeters is 1 centimeter, you should be able to do this. So my first step is I'm going to take the 765 millimeters, and I'm going to convert it to centimeters. To convert from millimeters to centimeters, I'm going to multiply by a unit or a fraction. In the numerator is what I want. I want to have centimeters. In the denominator is what I'm starting with. I'm starting with millimeters. And I was given, or gave you, that 1 millimeter is 10 centimeters. I'm going to do the work here. The millimeters are going to cancel. It's going to leave me my unit for centimeters. And to get the number, this is the division because the 10 is in the denominator. So I'm going to take the 765 and divide it by 10. I can do that in my head, but I won't. So this gives me 76.5 centimeters. Now I can do what the author wants me to do. I need to convert, I need to get an answer that's in inches, and now I'm going to use this unit. So now I'm going to take this, so second, for my second step, I'm going to convert from centimeters to inches. So it's possible that you might theoretically have to do 4 or 5 different conversions to get from the beginning number to the number that you want. But in this particular case, I just have to do 2. And I think there might be 1 problem in the homework that has 3 steps. But for the most part, 90% of the problems or more will be 1 step. So I'm going to take the 76.75 centimeters that I created in my first step. I'm going to multiply it by a fraction. And what I'm trying to get out is inches. So what I want, I put in the numerator. I'm trying to get rid of centimeters. What I have, I put in the denominator. And now I'm going to use this fact that I got from the table, that 1 inch is 2.54 centimeters. This particular fact that I used in the first step, that's not on page 461. That somehow is in the lecture for section 8.1 that you're not responsible for, so I'd give that to you. So now I'm just going to finish this up. My centimeters are going to cancel. I'm going to be left with my inches. And this is a division problem. I'm going to divide the 76.5 divided by the 2.54, and that's the number. And again, I'm going to round. My calculator gives me 30.118, and I'm rounding to 2 decimals again. The 8 in the third decimal position is going to tell me to round that 1 up to a 2. So I'm going to write 30.12, and the units are going to be inches. For every problem in this grouping between 9 and 23, it would be wrong if you just put a number down. You need units with your numbers. If you just give me a number and it's correct on a test and you forget your units when the units are the big deal, then you're going to lose a point or two. 18 and 20 are reasonably straightforward analysis problems. So if you're watching the video, this would be a great time to pause the video, do the 2 problems on the sheet, and check yourself. Again, for the problem 18 as well as problem 20, I don't know the equivalences, but I looked at the table on page 461. I found out the unit that compares ounces to grams says that 1 ounce is 28 grams. And then apparently there's regular tons, that's 2,000 pounds that I'm used to, and metric tons, and there's a relationship given on that page between T, which is our standard 2,000 pound ton, and the metric ton, which isn't 2,000 pounds. So even though I don't have a good familiarity with metric tons, I still could solve problem 20 as long as I can find the unit that's necessary. And again, all I do is I go to the page and I look for, in this case, I look 1 ton, regular 2,000 pound ton as 0.09 metrics. I imagine you pronounce that ton, but I'm not even sure. So pause the video, try to work each of these problems, and then when you turn it back on, you can see if you're right or if I screwed up, because I do make more mistakes than I should. So in this problem, I have ounces, I want grams, so in the numerator I'm going to put grams because that's what I want, and the denominator I'm going to put ounces because that's what I'm going to get rid of. I'm just going to put the numbers that I got from page 461 that says 28 grams is 1 ounce. I'm going to cancel the units. This is a multiplication problem because the 28's in the numerator. So to get the number for my answer, I'm going to multiply the 192 times the 28, and I get 5,376. Fraction is gone. The units that's left are grams, and you can write a G for grams, or you can just write out the full word. 20 is basically the same problem. I'm going to take my starting unit, which is 4 tons. I'm going to multiply by a fraction. In the numerator goes the unit that I want, which is the metric tons. In the denominator is the unit that I have, which is English 2,000 pound tons. And now I'm going to put numbers next to each. Again, the numbers that I got from the table. Didn't make up any of these. I cancel my units. Tons cancel with tons. And this is a multiplying problem because the 0.9 was in the numerator. The 0.9 was in the denominator. It'd be a dividing problem. I'm just going to go 4 times 0.9, and I get 3.6. So the number that needs to be my answer is a 3.6. And then I can write the tons, or if I want to, apparently the small t is the appropriate abbreviation for that. So next page has only one more problem from this grouping, and same thing. I'm going from a traditional acre to a hectare, I guess. Like I know what an acre lot is in Arizona. It's like 43,560 square feet, and the metric acre apparently is a hectare. And if I want to convert between the two, I need a relationship between the two. And I put down this relationship that I didn't know, that I just stole from that page. So I'm going to write down what I'm starting with. I'm starting with 6.2 acres. I'm going to multiply by a fraction. In the numerator, it's what I want to have. I want to come up with hectares. In the denominator, I'm going to write what I have. I have acres. I want to get rid of those. And I'm going to put numbers next to it. I have 0.4 hectares is 1 acre. The acres are going to cancel. I have to multiply the 6.2 and the 0.4 to get the number that I want. It's going to be 2.48. And I need to put either a word or a symbol next to the 2.48. I don't really have the room to write hectare, but apparently HA is the abbreviation that I can write in place of the word. When we go to a test, if you know an abbreviation and it's correct, you can use it or you can write the word out. So that's the first group of problems that I picked for homework in section 8.4. The last group of problems I picked were word problems between 39 and 57. And the problems look a little more intimidating, but ultimately they're not any different. They're just asking me to convert from one unit to another. And I just have to figure out what I'm converting from by reading the problem. So I picked a bunch of the even problems in this grouping, and I'll do a bunch of them. So problem 40 talks about the distance from Cincinnati to Columbus. So that's about 110 miles. It wants to know the distance in kilometers. So really, what I'm trying to do is I'm trying to convert 110 miles to kilometers. That's ultimately what the problem's asking me to do. This problem is friendlier than some because in some of the problems in this section there's distractor numbers that you don't need at all to answer the question. But the only number in this problem was 110 miles, and I can, by reading it, infer that the author wants me to convert the 110 miles to kilometers. The parenthetical comment, that's not given. If you look in the text, you won't see that. I just added that because I knew I needed it. So I'm going to take the 110 miles that was given, and I'm going to multiply. In the numerator, I'm going to write what I want. I want kilometers. I can write km for kilometers. I can write the word kilometers out. In the denominator, I'm going to put what I have. I have miles, and I'm going to use the units. That 1.6 kilometers is 1 miles. The miles will cancel. My units are going to be kilometers, which I can write the symbol or the word. If you know the abbreviation, that's fine. And to get the number, I have to multiply because the 1.6 is in the numerator. When I multiply 110 times 1.6, I get 176 kilometers. So every problem in this grouping between 39 and 57 will have this sort of feel. Though there's a whole word problem, and somewhere is embedded in the word problem the author wants me to do a conversion. I have to figure out the conversion that the author wants and then do the conversion. .42 is the beginnings of it becoming a little bit trickier, but the nice thing about 42 is there's only one number in the problem, so I know that I'm somehow going to work with the 80. So apparently the Queen Elizabeth Way, it's probably a highway in Europe, has a speed limit of 80 kilometers per hour. I'm trying to figure out the speed limit in miles per hour. Ultimately, what I really need to do, I need to take the 80 kilometers that I'm allowed to go in 1 mile in 1 hour and figure out how many miles that is. So basically, I'm asked to convert 80 kilometers to miles. And once I have that, I can say that's how many miles I'm allowed to go per hour. So I'm going to take what I have, 80 kilometers. I'm going to use km for kilometers. I'm going to multiply it by a unit. In the numerator, I'm going to put what I want. I want to have miles. In the denominator, I have what I have, which is kilometers. Now I'm using the relationship that I got from page 461, that 1 mile is 1.6 kilometers. And I'm going to solve the problem. I'm going to cancel out the kilometers. Because the 1.6 is in the denominator, I need to divide. So to get the number for my answer, I'm going to go 80 divided by 1.6. And I get 50, which is slow. So 80 kilometers is equal to 50 miles. So if I'm allowed to drive 80 kilometers per hour, that's going to be the equivalent of driving 50 miles per hour. So 80 kilometers per hour is the same as 50 miles per hour because 80 kilometers is 50 miles. So the speed limit in miles per hour is going to be 50 miles per hour. which is going to be the same as 80 kilometers because it's the exact same distance. .44 I probably should have made a whole page for because it's going to take 2 units. And again, if this problem sneaks its way onto a test, you're going to have all the units at your disposal. So as I read problem 44, it's just a short little problem that starts here. It says a swimming pool holds 12,500 gallons of water. What is the volume in kiloliters? So ultimately what I need to do is I need to convert the 12,500 gallons to kiloliters. I'm going to abbreviate that KL. I think that's the right abbreviation for that. So in order to do that, it would be nice if I had a relationship that I could find out that related gallons to kiloliters. And when I went for the relationship with gallons, the only relationship with gallons I see is gallons is related to liters. The fact that the only relationship I have relates gallons to liters, that's the only one I could use. That means I need to get my kiloliters into liters. So when I looked at my page, I had this relationship that 1 gallon is equal to 3.8 liters, which was nice, but I have kiloliters, so I have to do this in 2 steps. Step 1 is the metric conversion that you'd be good at if you did section 8.1, that you don't have to be that good at though. So in step 1, I'm going to convert from gallons, from gallons to liters. That's good, because I can do that. But that's not what I want, but it's what I can do right now. So I'm going to take the 12,500 gallons, and I'm going to multiply it by the I forgot the units here. 12,500 gallons, multiply by the unit. In the numerator, I put what I want liters. In the denominator, I put what I have gallons. Doing that computation right there is going to get me into liters. So the gallons are going to cancel, the liters are going to be left. And when I multiply 12,500 times 3.8, I get 47,500 liters. That would be an answer if the problem said what is the volume in liters, but it doesn't. It says what's the volume in kiloliters. So my step 2 is I need to convert from what I have now, liters, to what I want, kiloliters. And what I'll do is I'll take a fraction and multiply it by the 47,500 liters. In the numerator, I'm going to put what I want, which is kiloliters. In the denominator, I'm going to put what I have, which is liters. And now I'm going to use this relation that 1 kiloliter is equal to 1,000 liters. I'll be able to cancel the liters. Kiloliters are going to be left. And this is a dividing problem because the 1,000 is in the denominator. So I'll take the 47,500 divided by 1,000, and I get 47.5. And then kiloliters. So the answer to this problem, 12,500 gallons, is equal to 47.5 kiloliters. So every now and then we'll stumble across a 2-step problem, and that's going to be the case when we don't have a relationship that goes directly from the units that we want to the units that we have. So in this case, I want it to go directly from gallons to kiloliters. The only relationship I had involving gallons took me from gallons to liters, so I know I needed to do 2 steps. And this relation, that 1,000 liters is a kiloliter, this was a test question. I just give it to you because I don't expect you to know the metric measurements. So 46 talks about the area of Yosemite in square miles, and it wants me to convert from square miles to square kilometers. Basically, this problem wants me to convert 1,189 square miles to kilometers squared. And fortunately, the author gave me a relationship between square miles and square kilometers, so I can do this in one step. So I'm going to take the 1,189 square miles, using m squared to mean square miles, multiply it by a fraction. In the denominator, it's what I want to get rid of. In the numerator, it's what I want. I want square kilometers, which I'm going to write with a km with an exponent of 2. In the denominator, I'm going to put miles squared because that's what I want to get rid of. And the numbers that the author gave me is that 2.6 square kilometers is 1 square mile. The units are going to cancel. The miles are going to cancel, should I say. I'm going to be left with kilometers squared. And this is a multiplying problem because the 2.6 is in the numerator. So if I just multiply the 1189 times the 2.6, I'll get the number that goes in my answer, which is 3,091.4 square kilometers. So the area of Yosemite National Park is 3,091 square kilometers. $50 is the hardest, well, if not the hardest problem, one of the hardest problems. And before I came here, I worked 50 out to try to come up with a nice way to explain it. And I'm not sure that the way that I explain it is going to be the ultimate best way. But this is the way that I think the author would want us to do it. It's definitely not the only way. If you pause the video and you work this out and you get the same answer as me, then your answer is okay. If you have no idea how to get started, then you just watch what I do, and what I do is something you can duplicate if I was cruel enough to put something like this on a test. So what I decided to do is first, so my goal is to figure out how much per gram the perfume costs, and in order to figure out how much per gram it costs, I'm going to convert from ounces to grams. So I'm going to take this, so first I'm going to determine the weight of the bottle in grams. I'm going to ignore the $80 for a while. So what I have is the bottle weighs 0.25 ounces, and I want to find the weight in grams, and I'm going to use the unit that says 1 ounce is 28 grams, and I stole that again from the table on page 461. So in the numerator, I'm going to write my 28 grams. In the denominator, I'm going to write my 1 ounce. My ounces are going to cancel. My number now is going to turn into grams. And if I multiply 0.25 times 28, I get 7 grams. From this point, I suspect a lot of you can figure out the cost of 1 gram without using unit analysis, and that's completely fine. So if this inspired you enough to figure out if if 7 grams costs $80, how much does 1 gram cost? That's kind of where I'm at now, basically. If 7 grams cost $80, how much does 1 gram cost? Then if you can answer that without unit analysis, that would be great. Our author would want me to do this. So second, I'm going to convert from grams to dollars. And what I have is 7 grams. And I know that, oops. I'm sorry, I want to find the cost of 1 gram. So this way it's so non-intuitive that I stumble. So I want to find the cost of 1 gram. To find the cost of 1 gram, I'm going to multiply by a unit. And what I know is that 7 grams costs $80. So this is multiplying by 1. And it's changing from grams to dollars. I would just divide by 7 to do this. taking the $80 divided by 7 grams, that gives you the cost per gram. But using a unit analysis, it's very sneaky, tricky. But if I want to find the cost of 1 gram, I'm going to convert from grams to dollars, and I know that $80 is equal to 7 grams. And the grams are going to cancel. To get the number, I'm going to multiply. I'm going to go 1 times 80 divided by 7. I'm not terribly happy with this explanation, to say the least, but this is the way I think our author would envision us to do this. And if I did that, I get 11.42. I'm just going to round it. I'll round it to 11.43 because I'm dealing with money. My work came out to 11.428. I'm going to take the 2 and round it up to a 3, and my units are going to be dollars. So this is what the author would want me to do. If I got to this point right here, and I understood that that's the question, if you just take the 80 and divide it by 7, that's going to give you the cost per ounce. Because dollars per gram, should I say, you divide dollars divided by gram, and you get dollars per gram. Ask me in class to do this again if you didn't like it, or ask me to make up problems like it so you can see a couple of them, because I don't know if one is going to be enough to inspire you to be able to do any problem in the homework that's like this. But the first step is kind of you have to do, because I want the cost per gram and I'm given something in ounces. I need to find out how many grams I have. And then once I know the units, how many grams I have, I don't really need to use unit analysis. I could have just took the $80, divide it by the 7 grams, and that would give me the cost of 1 gram. And that's kind of what I did here, but I tried it in a fancy way that's probably more confusing than it's worth. Let me just bury this and move on to the next problem. The next problem's a little bit tricky because it has a fraction in there, but it's not so tricky. So the author gives me a unit in this problem. The author doesn't often give me units, but the author in the very first sentence says that 1 gram is the same as 5 carats, and David has a ring that has a stone in it that's 1/8 of a carat. I want to find the weight in grams. So basically, I want to convert 1/8 of a carat to grams. That's ultimately what I'm asked to do here. 1/8 isn't going to be an easy number to work with, so let me get rid of this. I'm going to go 1 divided by 8. 1/8 as a decimal is 0.125. So better, the author's asking me to convert 0.125 carats to grams. Now I'm going to use that unit that the author gave me. So I'm going to start with what I have. I have 0.125 carats. And I'm going to multiply it by a unit. In the numerator, I'm going to put the unit that I want, which is grams. In the denominator, I'm going to put the unit that I have, which is carats. And then I'm going to use what the author gave me. The author gave me that 1 gram is the same as 5 carats. The carats are now going to cancel. My answer is going to be in grams. It's going to be a small number. I'm going to take 0.125 and divide it by 5. And I get 0.025 grams. And that's the decimal ended by itself. So I live with that, just happy, and write that for an answer. If I wanted to, after I did this computation, I did 0.125 divided by 5. I got a decimal answer. If I really had the desire to put this into a fraction, because the original problem, the units were given in fractions, there's a chance that the author might prefer a fraction. On the TI-83 or 84 calculator, to make a decimal answer into a fraction, you hit your math button. The math button is in the far left-hand column, about 4th down. And then you hit the enter button 2 times. So I hit enter once, and then enter again, and it gives me 1/40. And so it would be an acceptable answer to say that this is 1/40th of a gram. Both are fine. So this was an odd problem in that the author actually gave me the unit that he wanted me to use. Similarly, the next problem, I think the author gives me the unit that he wants me to use. And That's tough. So the author gives me that 1 foot is 30 centimeters. That's nice, but it's not terribly helpful because I'm trying to convert from square meters to square feet. Really? Find the equivalent of 1 square meter in square feet. Huh. So I want to so I know that 1 foot is 30 centimeters, and I want to get in square feet. So this problem is a bad unit that the author gave me. So immediately when I look at the problems, I see meters, I don't see centimeters. Let me start off in this problem by converting the 30 centimeters to meters. And I'm going to use a unit that's not given, that I'd give you on a test, that 100 centimeters equals 1 meter. And if I do this conversion, I'll take 30 centimeters times 1 meter is 100 centimeters. My centimeters will cancel. I'll take 30 and divide it by 100. And I get 0.3 meters. So I'm going to modify the information that the author gives me. I'm going to say that 1 foot is about 0.3 meters. And the reason I'm doing this is because the author wants me to convert from square meters to square feet, or cubic meters to cubic feet. So this is the beginning. Getting that 30 centimeters to meters is a nice place to start because it's going to give me the ability to do the work. But we haven't done any work like this yet. If you've had chemistry, then likely you can do this without me helping you. But this is converting square units to square units, and I don't have, unfortunately, square units in my relationship. So I want to take 1 square meter, which I'll write as 1 meter squared, and I want to convert it to 1 square feet, or in square feet. So the units that I'm starting with in this problem, once I've converted this 30 centimeters to meters, I'm starting with square meters, and I want to come up with square feet. That's a bit tricky to do. So instead of square meters, I'm going to change that to meters times meters, because squaring means to multiply by itself. So I'm going to take 1 square meter, which is 1 meter times 1 meter, and I'm going to change it to square feet, which is feet times feet. And in order to get that, using the unit that the author gave me that I improved upon, I'm going to multiply by the relation that 1 foot is 0.3 meters. In the numerator, I'm going to put what I want. I want to have feet. In the denominator, I'm going to put what I have. I want to get rid of, or what I have, and I want to get rid of meters. If I multiply by that unit, that 1 foot is equal to 0.3 meters, what's going to happen is one of the meters from the square meters is going to cancel with the meters, but my units aren't going to be square feet, because to get square feet, I have to multiply feet by feet. My units are going to be meet feeters, I guess, because this meter is going to be left and that foot is going to be left. This isn't enough for this problem. To convert from square units to square units, if you don't have the relationship with squares, you have to multiply by 2. So I'm going to multiply by that same factor again. And the second time that I multiply, the meter in the denominator will cancel with the meter that's left from the square meter. And you'll see the units that I have left are feet times feet. And feet times feet give me the unit of square feet. So this multiplication, multiplying by 2 units, is going to get me to my answer. And in order to get to the answer, I'm going to do this. I'm going to go 1 divided by 0.3, and then divide it by 0.3 again. And so I'll do the all in once on my calculator. I'm going to go, the one that I have here, each of the 0.3s is in the denominator, so I'm going to divide it. We'll go divide it by 0.3, and then divide it by 0.3 again. And I get 11.11111 square feet. And I'm rounding to 2 decimals again. The number in the third decimal place is a 1 that you barely can see, and that tells me not to round up. Part B wants me to convert from 1 cubic meter into cubic feet. So I'm starting with cubic meters, and cubic meters are meters times meters times meters. So the unit that I'm starting with is 1 meter cubed, which is 1 meter times meter times meter. And my goal is to get my answer out in cubic feet, and cubic feet is feet times feet times feet. To do the work here, first I'm going to multiply by a fraction that takes me from the unit that I have to the unit that I want. If I just do this once, if I multiply by 1 foot is 0.3 meters, that cancels out 1 meter, but leaves me with 2 meters and a foot. In my final answer, I don't want any meters, but I want feet. And so I'm going to do this 2 more times. The second time that I multiply by 1 foot is 0.3 meters. The second m in the denominator cancels with the second m from my meters cubed, because meters cubed is meters times meters times meters. And then the last, I'm going to cancel and cancel. And then what's left in terms of units is feet times feet times feet. That's going to give me the feet cubed that I'm looking for. And now I'm going to multiply. I'll go 1 divided by 0.3, divided by 0.3, divided by 0.3. So go 1 divided by 0.3, divided by 0.3, divided by 0.3, because all the 0.3s are in the denominator. And I get 37.0. Well, my calculator gives me 37.037. I'm going to round out to 37.04 cubic feet. Instead of me doing the problem that I planned on doing, let me do the problem that's just like this. And that would be problem number 55. So I'm going to do, instead of doing problem 57, which isn't as tricky, but there's some trick to it, I'm going to do problem 55. So problem 55 tells me that 1 meter is about 3.3 feet. So I'm going to just write this down because I haven't typed it up yet. So problem 55 tells me that 1 meter is about 3.3 feet. In part A, I'm asked to find the equivalent of 1 square meter in square feet. This problem's a little bit friendlier than the one that I did. The one that I did, the units didn't match up. Here, I'm going from meters to feet. I have a relationship between meters and feet, but it's not square units to square units. So I'm going to convert. So my goal is to convert 1 square meter, which is 1 meter squared, to square feet, which is feet squared. So I'm going to start with what I have, which is 1 meter squared, or 1 meter times 1 meter. And my goal in units is to get square feet out. Because the unit that I have doesn't cancel, it's not a square to square, I'm going to need 2 units. So the first unit I'm going to multiply by, in the numerator it's going to put what I want. I want feet, so I'm going to put 3.3 feet is equal to 1 meter. And what that's going to allow me to do, it's going to cancel 1 meter. If I didn't do anything else, my units and my answer would have a meter times a feet, and that's not good. So I'm going to do this one more time. I'm going to multiply by 3.3 feet is 1 meter. That's going to cancel out a meter. The units that are going to be left in my answer are going to be feet times feet, which is square feet. That's what I'm searching for. And the number I'm going to get by multiplying 1 by 3.3 by 3.3. So to get the number that goes in front of my square feet, I go 1 times 3.3 times 3.3, and I get 10.89 feet squared for the answer to 55. Part A. The nice thing about this is this happens to be an odd problem. So section 8.4, 55A, anytime I do an odd problem, I have the luxury of thumbing into the back of the book and searching for the page that has that answer. So 8.4, not that you can probably read this, but 55A, the author gives me 10.89 square feet. For the next problem, on part B, I'm trying to get 35.937 feet cubed. So I should probably remind myself that I'm searching for 35.937 cubic feet. And what part B wants me to do in this problem, if I read this, it says that basically I want to find the equivalent of 1 cubic meter in cubic feet. So I want to convert 1 cubic meter to cubic feet. So I'm starting with 1 cubic meter, which is the same as 1 meter times meter times meter, because cubic is 3 multiplications. And my goal is to get foot cubed, and foot cubed is feet times feet times feet. And in order to do this, I'm going to multiply by the same fraction 3 times, because each time I multiply by 3.3 feet is 1 meter, it cancels out one of the 3 meters and gives me one of the 3 feet that I need. So for this problem, if I multiply by 1 meter over 3.3 feet over 1 meter, each fraction is going to cancel a meter, and the units I'm going to have left are feet times feet times feet, which are going to be feet cubed. And to get my number, I'm going to multiply this 1 by that 3.3, by that 3.3, by that 3.3. It's all multiplying because the 3.3s are in the numerator. So I'm going to go 1 times 3.3 times 3.3 times 3.3. And I get 35.937, which is magically the number that the author gave me, which is a beautiful thing. All right, I think I'll stop there, and hopefully you can do most of the odd problems that were given for homework in that section. If not, I'll have ample time in class to answer any of your questions, or you can send me an email. The nice thing is with the homework problems, they're all odd problems. You can check your answers to the back of the book. If you can't figure out what the answer is, you might be able to figure out how to get the answer just with playing with some numbers. And if you can't, I can definitely try to inspire you and help you out. All right, hopefully that was reasonable.